Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 6 video on the topic of relative density from the chapter of Physical Quantities and Measurements. So this video is part of the playlist ICSE Physics for class 8 where I only discuss about the key concepts and formula related to numerical solving. In the previous part 5, I solved the first set 1 of 10 problems on the relative density, and in this part, I will solve another 8 MCQ problems on relative density. So, I think there is a mistake. In part 4, I discussed about the concepts and formula of relative density. So, these MCQs, these 8 MCQs of set 1 and the previous 10 MCQs of set 1 is based on the video part 4 on relative density. So if you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 6 video, where I will solve another 10 MCQ problems on the topic of relative density. Okay, so the first problem says the relative densities of two substances P and Q are X and Y respectively. What volume of a body made of P will weigh equal to the body made of Q having a volume of Z centimeter cube? So there are two substances P and Q. The relative densities are given as X and Y. So what is given? Relative density of P is given as X, and relative density of the substance Q is given as Y. Okay, and it is asking what volume of a body made of P will weigh, that is the weight of what volume of a body made of P will be equal to the weight of a body made of Q, and that body made of Q is having a volume of Z centimeter cube. Okay, so if we consider, let's say this is the body made of P and this is the body made of Q. Uh, so so okay, so the volume of the body Q, volume of the body made of Q is given to be for this it is given to be Z centimeter cube, and okay, and the relative density of the substance Q is Y. So we can say that the density of the substance Q will be Y gram per centimeter cube. We know that if the relative density is of a substance is Y, then its density will be Y gram per centimeter cube, or Y into 1000 kilogram per meter cube. Okay. Now for the body of made of P, let's say the volume required is, let's say V dash centimeter cube. We have to find V dash. Also we know the relative density of the substance P is given to be X. So we can say the density of the substance P will be X gram per centimeter cube. Okay. Now the problem says that the what volume of a body made of P will weigh equal. That is the weight of the body made of P is equal to the weight of the body made of substance Q. This means that the mass of the body of P will be equal to the mass of the body of made of Q. So what is the mass over here? In this case, if I consider MP to be the mass is V dash rho this much gram, which is equal to V dash rho is given, rho is x, so v dash x, this much gram. And what is the mass of the body made of Q? Let's say if we denote it with the mass, if we denote the mass of the body of Q as mq, it will be V into rho, rho Q. This is V is given to be Z, and rho Q is Y. So Zy gram, Zy gram. Now these two, MP has to be equal to MQ because it is given the weight of the body of P. Now what is weight? The weight of, what is weight of the body of P? If the weight of two bodies are same, it means that their masses are same, because what is weight? Weight of the body P is nothing but its mass multiplied by G. This G is a gravitational, it is acceleration due to gravity. It is a constant value which is 9.8 meter per second square. Similarly, W, weight of the body made of Q is nothing but M, its mass MQ multiplied by G. So so it is given that the weight are equal. So WP is equal to WQ. This implies the G will cancel from both the sides. So this definitely means that MP is equal to MQ. So whenever it is given that weight of two bodies are equal, the weight is usual. If nothing is mentioned, then the weight is usually measured on the surface of the earth. So in that case, if the weight of two bodies are same, it means that the mass of the two bodies are same. So we have MP equals to MQ. This implies, what is MP? MP was V dash X. This should be equal to, and MQ was ZY. So this implies V dash, the volume that we have to find is ZY by X, this much centimeter cube. So the answer should be Zy by X, centimeter cube. So the correct choice is C. C is the correct choice. Okay, let's see the next problem. The density of an ice cube is 10x kilogram per meter cube. If the relative density of the ice cube is Y, then the ratio x is to y is. Okay, so what is given? The relative density of ice is given to be y. Also, the density of ice is ice cube. The density of the ice cube means, it means, okay, so the density of the ice cube is given as 10x kilogram per meter cube. Now, whenever you solve numerical problems, always be consistent with what unit of system you are using. For the problems related to density or relative density, either you use SI system or CGS system. Okay, now I have this. Now I know that the relative density and the density are related to each other by a formula. So if the relative density of the ice is Y, from here I can say that the density of ice will be equal to Y gram per centimeter cube. In the problem, the density is already given in kilogram per meter cube. Okay, now if I convert the given density in kilogram per meter cube to CGS system, this will be 10x multiplied by 10 to the power minus 3 gram per centimeter cube. As we know that 1 kilogram per meter cube is equal to 10 to the power minus 3 gram per centimeter cube. Now clearly, now we can say that we can equate these two values as they are same. They are both the value of density of ice. So I can say that y is equal to 10x multiplied by 10 to the power minus 3. This is, if I simplify the right hand side, it becomes x by 100. So this implies the problem has asked the ratio of x is to y. So from we got y equals to 10x, y equals to x by 100. So from here we can say x by y will be equal to 100 by 1. So this implies x is to y is nothing but 100 is to 1. So the correct choice is C. Now, if I do any kind of calculation mistake, or if I apply any concept incorrectly, or if I do any kind of mistakes in using the units, or using incorrectly applying the formula, then please feel free to let me know in the comment section. I will appreciate that. Let's see the next problem. It says that the quantity thermal expansion coefficient. So this is a quantity thermal expansion coefficient, which is denoted by the symbol gamma. So this is gamma. This symbol is gamma. For a substance is defined to be the change in volume of the substance per unit change in temperature. So that is, gamma for a substance is nothing but the change in its volume per unit change in temperature. Okay. So basically it is change in volume divided by change in temperature. Okay. If I consider in physics, usually a change in quantity is denoted with the triangle symbol. So this means triangle. This is actually in physics, in the physical term, it is known as delta. So this is gamma is delta V by delta T. Delta T means a change in temperature, and delta V, that is in the numerator we are having delta V, which means a change in volume, and in the denominator we are having delta T, which is the corresponding change in temperature. That is, when the change in temperature is delta T, the change in volume is delta V. So the ratio delta V by delta T is the gamma, which is known as thermal expansion coefficient. This is usually constant for different substances. So it is given that a body having gamma, which is equal to, so definitely the unit of gamma will be unit of volume divided by unit of temperature. So you can say it will be kind of integers system, centimeter cube, you can say per degree Celsius. Okay. So it is given a body having gamma x centimeter cube per degree Celsius, which means that for the body for 1 degree Celsius change in temperature, the volume is the change in volume is x centimeter cube. So a body having gamma x centimeter cube per degree Celsius is heated from T1 degree centigrade to T2 degree centigrade. Okay. If the density of the body at T1 degree centigrade is sigma gram per centimeter cube and has a volume of V centimeter cube, then what will be the relative density of the body at T2 degree centigrade? Okay. So definitely at T1 degree centigrade, at two different temperatures, which in this problem is T1 degree centigrade and T2 degree centigrade, the density will change. We know that the body has certain mass. The mass will never change. If you since it is being heated, it will expand, and when it expands, the density becomes low. So clearly, the density at T2 degree centigrade will be less than the density at T1 degree centigrade, because the body is being heated from T1 degree centigrade to T2 degree centigrade. Okay. So let's okay. So what is in this problem? What is delta? What is delta T? That is the change in temperature is T2 minus T1 degree Celsius is the change in temperature. Okay. At T1 degree centigrade, the density is given to be rho sigma per centimeter cube. Okay. Now let's visualize the concept. Let's say this be the body at T1 degree Celsius. So it is being heated it is being heated, and the body, this is the body at T2 degree Celsius. Okay. So delta T, that is the change in temperature, is T2 minus T1. T2 minus T1. So what will be from the gamma? We can easily find out what will be the change in volume. So from this formula, we can say that the change in volume is equal to change in temperature multiplied by gamma. So for this problem, the change in volume will be equal to gamma multiplied by T2 minus T1. Okay. It is also given that at T1 degree centigrade, the volume of the body was V centimeter cube. Okay. Please note that this delta V is a positive volume, because when the temperature is becoming more, the body expands. So definitely the change in temperature will be positive. So at T1 degree centigrade, the volume was V centimeter cube, and the change in temperature and the change in volume is delta V, which is gamma multiplied by T2 minus T1. So what will be the volume at T2 degree centigrade? It will definitely be the initial volume, that is the volume at T1 degree centigrade, plus the change in volume, V plus delta V. This is equal to V plus delta V is gamma multiplied by T2 minus T1. So this is the volume of the body at T2 degree centigrade. Okay. Now the question has asked what will be the relative density of the body at T2 degree centigrade. To find the relative density, we obviously have to find the density of the body at T2 degree centigrade. Okay. Now let's say, okay, also at T1 degree centigrade, the density was given to be sigma. Okay, I mean sigma gram per centimeter cube. Okay, let's say the density of the body at T2 degree centigrade is sigma dash gram per centimeter cube. We are assuming the density at T2 degree centigrade of the body to be sigma dash. We have to first find sigma dash. If we can find sigma dash, then from the density we can easily find its relative density. So now we have to find sigma dash. Now definitely the mass of the body is not changing. So at T1 degree centigrade, the mass was, if I consider it to be m1, the mass will be volume into density. So it will be V into rho this much gram. And at T2 degree centigrade, the mass, if I consider it to be m2, will be its volume into density. Density we have assumed to be rho dash, and the volume we know is V plus sigma into T2 minus T1. Okay. Now clearly the mass is not changing, mass is constant. So m1 will be equal to m2. So m1 will be equal to m2, as mass is constant. Mass is constant. So this implies we have V rho should be equal to rho dash multiplied by, we have V plus gamma into T2 minus T1. So from here we can easily find gamma dash. So rho dash will be equal to Vp V rho multiplied by V plus gamma into T2 minus T1. So this is the density of, obviously this will be in, now please note that while solving problems, I will in many times, in many places, I will not mention the unit. I hope you will understand. So this is the density of the body at T2 degree centigrade. So now we can easily find its relative density. if you know the density of a body in gram per centimeter cube, then the relative density will be the value of the density. So this implies RD, uh, RD, uh, RD of the relative density of the substance at T2 degree centigrade is nothing but V rho divided by V plus gamma T2 minus T1. So this must be the answer. Let's see, V rho divided by V plus gamma into T2 minus T1. So choice A is the correct choice. Let's see the next problem. Question number 4. A bottle when filled with a liquid L weighs W1 GMF. That is, the mass of the bottle filled with liquid L is W1 gram. When the bottle is filled with water at 4 degrees centigrade, it weighs W2 GMF. That is the mass of the bottle along with the water completely filled with water is at 4 degrees centigrade is W2 gram. If the relative density of liquid L is X, then the mass of the empty bottle is. Now definitely the mass in W1 and W2, W1 is the mass of the empty bottle plus the liquid L, and W2 is the mass of the empty bottle plus water at 4 degrees centigrade. Okay, we have to find the mass of the empty bottle. Okay, so let's say let M, since the units of the mass are given in gram, let's say M gram be the mass of empty bottle. Okay, now okay, when the bottle is filled with water at 4 degrees centigrade, if the relative density of liquid is if the relative density of the liquid L is given, okay, now we have to find the mass of the, okay, so I need to obviously when the so W1 gram is the mass of bottle plus liquid L, where the volume of the liquid L is the capacity of the bottle, and W2 gram is the mass of the empty bottle plus water at 4 degrees centigrade, and here also the volume of the water is the capacity of the bottle. So the volume of the water at 4 degrees centigrade is equal to obviously is equal to the volume of the liquid, because in both the cases the bottle is being completely filled with the liquid and water. Okay, so just try to let's say this is the bottle. I don't know, it's looking weird. So let's say let M be the mass of empty bottle. Okay, let M be the mass of empty bottle. Let V centimeter cube be a capacity, the capacity of the bottle. That is, it can, that is the volume of the empty bottle. That is, it can store V centimeter cube of any liquid or water. So I am assuming V centimeter cube to be the capacity of the bottle. Okay, so this will imply that volume of water when the empty bottle was filled with liquid. So volume. So this will imply, no, let's say let M1 gram be the mass, of liquid L, liquid L, that is m1 gram be the mass of the liquid L which is completely filling the bottle. Also let m2 gram be the mass of water at 4 degree centigrade. So we can clearly say that volume of m1 gram of liquid L is equal to the volume of m2 gram of water at 4 degrees centigrade, which is equal to, we have assumed to be V centimeter cube. Okay. Now, so this is the scenario. We have considered the mass of the liquid L, which is completely filling the empty bottle. That is the mass of the liquid L of volume V centimeter cube is m1 gram. Also, the mass of the water at 4 degrees centigrade of the same volume, that is V centimeter cube, is m2 gram. We are assuming this. So we have assumed the volume of the empty bottle, that is V centimeter cube, and we have assumed the mass of the liquid and the water. Okay. Also, we have assumed small m gram to be the mass of the empty bottle. Okay. So what now, based on the given information, what equation we can make? So in the first case, it is saying that the mass of the bottle when filled with the liquid L weighs W1 gram. So this means that the mass of the bottle, which is small m, plus the mass of the liquid, which is m1, should be equal to W1. Okay. In the second case, similarly, we will have the mass of the bottle plus the mass of the water should be equal to W2. Okay. Now, we have to find the small m, mass of the bottle. Okay. Now, from here, from the first equation, we get the mass of the liquid m1 to be W1 minus small m, and from the second equation we get m2, that is the mass of the water at 4 degrees centigrade, to be W2 minus small m. Now, what is the relative density of the liquid L? Relative density of the liquid L is nothing but, we know an alternative formula for relative density of substance. It is the mass of a certain volume of that substance divided by the mass of that same volume of water at 4 degrees centigrade. So we can clearly say that the relative density of the liquid L will be m1 by m2, since both the m1 since m1 gram of the liquid L is occupying a volume of V centimeter cube, also m2 gram of water at 4 degrees centigrade is occupying V centimeter cube. So we have this. Now this implies the relative density of the liquid is given to be x. So we can say x is equal to m1 by m2. Now this is equal to m1, we know, is W1 minus small m, and small m2 is W2 minus m. So we get a linear equation in the small m. We have to find the unknown is small m. So we have x equals to W1 minus m divided by W2 minus small m. We have to find this is you can consider this as a linear equation in small m. So if you do cross multiplication, we get x multiplied by W2 minus small m is equal to W1 minus small m. If I simplify and bring all the m terms, all the terms having the small m to the left hand side and all other terms to the right hand side, I will get m minus xm is equal to w1 minus xw2. Okay, so this implies from the left hand side, if I take m common, m 1 minus x is equal to w1 minus x w2. So this implies m is equal to w1 minus x w2 divided by 1 minus x. This should be this much gram should be the mass of the empty bottle. So w1 minus x w2 divided by 1 minus x. Oh, okay. So let's in the choices it is given x minus 1. So I can rearrange and simplify the answer to be x w2 minus w1 divided by x minus 1. So x w2 minus w1 divided by x minus 1 should be this much gram should be the mass of empty bottle. So the correct answer should be choice D. D is the correct choice. Okay, let's do the next problem. Question number 5. The ratio of a relative density of two liquids A and B is m is to n. V centimeter cube of liquid A is homogeneously mixed with 2V centimeter cube of liquid B. The resulting mixture has a density of rho gram per centimeter cube. Find the density of liquid A. Find the density of liquid A. Okay. The ratio of the relative densities are given of liquids A and B. Find the density of liquid A. Find the density of liquid A. The ratio of okay. The ratio of relative density of two liquids A. Okay. It is asking the problem is asking to find the density of liquid A. Density of liquid A. The density of liquid A. Okay, so first of all, we need to understand that when two liquids having different densities, when certain are mixed together, when a certain volume of the liquid A is mixed with a certain volume of liquid B, and the liquid and the A, and both are having different densities, when they are homogeneously mixed, then how do we find the density of the mixture? So I already solved this kind of problem in the previous video. Okay, let's do it once again. So let's say this is the liquid. So this is the liquid A. Let's say it is given that the liquid A, V centimeter of liquid A, so the volume is V centimeter cube, was mixed with this is, let's say, B, liquid B. 2V, its volume is 2V centimeter cube. Let's say the density of the liquid A be rho A, and the density of the liquid B be rho P. Let's say obviously this will be rho A is in gram per centimeter cube, and we have rho B gram per centimeter cube. We are assuming that the density of liquid A is rho A and the density of liquid B is rho B. Okay. Now, when these two liquids A and B are homogeneously mixed, then let's say this is the resulting liquid. This is the resulting liquid let's say, so its volume definitely will be the sum of the volume of liquid A and B, which is V plus 2V centimeter cube, that is 3V centimeter cube. Now we don't know what will be the density of the resulting mixture. Let's say the density of the mixture is rho gram per centimeter cube. Okay. In the problem, the density is given. The density of the mixture is given to be rho gram per centimeter cube. Okay. So rho is already given. This is given. The density of the mixture is rho gram per centimeter cube. Okay. Also, one concept is that the mass of liquid A plus the mass of liquid B will be equal to the mass of the resulting mixture, because mass is not changing. So, what will be the mass of the liquid A? The mass of the liquid A will be the mass of the liquid A. Also note that we have considered the density of liquid A to be rho A and the density of the liquid B to be rho B. Now, so what will be? Okay, so the mass of liquid A is V rho A, this much gram, and the mass of the liquid B will be 2V rho B, this much gram. The mass of liquid A is V into rho A gram, and the mass of the liquid B is twice V into rho B gram. And the resulting mixture, the mass, if I consider it to be M, will be equal to 3V rho this much gram. Okay. Now, also note that the ratio of the relative density of the liquids A and B is given to be M is to N. Now, so what is the relative? What will be the relative density of liquid A? We have assumed the density to be rho A. So rho A gram per centimeter cube. So definitely the relative density of A is rho A. Similarly, the relative density of liquid B will be equal to rho B. So it is given that rho A by rho B is given to be, the ratio is given to be M is to N. So we have rho A by rho B equals to M by N. Okay. So this implies that N, if I do cross multiplication, N into rho A is equal to M into rho B. The problem has asked to find the density of liquid A. Okay. So this implies rho B should be equal to N by M into rho A. Okay. Now let's apply the concept that the mass of liquid A plus the mass of liquid B will be equal to the mass of the resulting mixture. So we have Ma plus Mb should be equal to M. So this implies, what is Ma? Ma is V into rho A gram, plus what is Mb? Mb is twice V into rho B, this much gram. This should be equal to, the mass of the mixture is 3 V rho. We have this. Clearly, you can see we can cancel out V from both the LHS and RHS. So this will be, if I take common V in the LHS, we have V into rho A plus 2 into rho B is equal to 3 V rho. So we can cancel out V from both sides and we get rho A plus twice rho B is equal to 3 rho. Also we know that rho B is equal to n by m multiplied by rho A. So if I substitute the value of rho B in this equation in terms of rho A, we get rho A plus 2 into rho B is n by m rho A. This should be equal to 3 rho. This implies if I take rho A common from both in the LHS, I have rho A multiplied by 1 plus twice n by m is equal to 3 rho. If I simplify the LHS further, I have rho A multiplied by twice n plus m, this whole divided by m is equal to 3i's rho. So this implies rho A will be equal to 3 rho m divided by m plus twice n. So 3 rho m divided by m plus twice n, this should be the density of liquid A. Obviously, this will be in gram per centimeter cube. Let's see the choices. This is in, bear in mind that this is in gram per centimeter cube. 3 rho m divided by m plus twice n. 3 rho m divided by, if I consider the choices given in CGS, the choices are A and B. So definitely choice A is incorrect because the correct answer is 3 rho m by m plus twice n. Choice A is correct and also choice B is incorrect. So definitely now we have to see whether between choice C and D which is correct, and both the choice C and D are given in CGS. So let me convert the density to CGS to SI, that is to kilogram per meter cube. I know this will be 3 rho m. For converting the value of density from CGS to SI, we just multiply it with 10 to the power 3, that is 1000. So this becomes m plus twice n multiplied by 10 to the power 3 kilogram per meter cube. Okay, now let's see which choice is correct. 3 rho m by m plus twice n multiplied by 10 to the power 3 kilogram per meter cube. So choice D is the correct choice. Okay, let's see the next problem. Question number 6. A bottle having a capacity of x ml when filled with water at 4 degrees centigrade weighs y gmf. That is the mass of the bottle. What is given? The volume of the bottle is given to be x ml, and when it is completely filled with water at 4 degrees centigrade, the bottle plus the water is weighing y gmf, which means that the mass of the bottle and the mass of water having a volume of x ml is y gram. If the outer volume of the bottle is zml, then the relative density of the bottle is, we have to find the relative density of the bottle. Now certainly the bottle has some thickness. Let's say this be the bottle. The bottle has some thickness. So this shaded part is actually the thickness of the bottle. Shaded part. And the capacity, so this much, the inside, the XML, x milliliter, which is the capacity of the, capacity of the bottle. So this volume in this figure, the volume of the inner square, if you consider now the shape of the bottle may not be a square one, it could be a round one. just for the sake of discussion, I have considered the shape of the bottle to be a square one. So this volume, so this the inside of the bottle, it is completely filled with water at 4 degrees centigrade, and so the volume of the water, the volume of water at 4 degrees centigrade is given to be x milliliter. The capacity of the bottle is given to be x milliliter, which essentially means that if it is completely filled with water, the volume of the water will also be x ml, which is nothing but x centimeter cube. 1 milliliter is equal to 1 centimeter cube. Okay. Now, if the outer volume of the bottle is Zml, then relative density of the bottle. Now, the problem is asking the relative density of the bottle. How do we find the relative density of the bottle? We need a certain mass of the bottle and the volume of the bottle. Obviously, since the bottle has some thickness, what will be the volume of the bottle? What will be the volume of the matter of the bottle, not the capacity. The volume, it is given that the outer volume of the bottle is Zml. So I can say, I hope you will understand, if I say volume of bottle content, not the volume matter, the content, that is the solid part of the bottle, not the inside, not the empty space, but the solid part of the bottle. The volume of the solid part of the volume of solid part of bottle will obviously be the volume of the outer volume of the bottle, which is given to be Z milliliter, that is Z centimeter cube, minus the capacity of the bottle, which is X milliliter. So Z minus X centimeter cube will be the volume of the solid part of the bottle. Okay. Now, okay. So we got the volume of the solid part of the bottle. Now we need to find what will be the mass of the empty bottle. If we can find the mass of the empty bottle, then we can find the density of the bottle. How do we find the mass of the empty bottle? Okay. Now it is given. Okay. Now it is given that. Okay. So let m, small m, be equal to mass of empty bottle. Let, that is the solid part of the bottle, let small m be the mass of solid part of the bottle. Okay. And let m dash is equal to mass of water, mass of, that is x ml of water at 4 degrees centigrade. This will imply, it is given in the first statement, says a bottle having a capacity of x ml when filled with water at 4 degrees centigrade weighs y gmf. So we can say that the mass of the bottle, mass of the empty bottle, that is small m, plus the mass of the water that is filling the entire bottle, that is the mass of x ml of water at 4 degrees centigrade, which we have considered to be m dash. This should be equal to y. This should be equal to y. Okay. Now, do we know m dash? I think we will know, we can find m dash, because we know since the water is at 4 degrees centigrade, we know that, and the volume of the water is x centimeter cube. So we know that since the density of water at 40 degrees centigrade is 1 gram per centimeter cube, we can say that 1 centimeter cube of water at 4 degrees centigrade has mass 1 gram just by using unitary method. So this will imply, since the volume of the water in this case is x centimeter cube of water at 40 degrees, so x centimeter cube of water at 40 degrees centigrade will have a mass of definitely x gram. So we can say that in this problem m dash is nothing but x gram. So this implies small m plus x is equal to y. This implies small m is equal to y minus x, this much gram is the mass of the empty bottle. Okay, so definitely sigma, if we consider sigma to be the density of the bottle, then we can say sigma will be equal to the mass of the empty bottle, which is y minus x divided by the volume of the solid part of the bottle, which is z minus x. This much gram per centimeter cube should be the density of the bottle. Obviously, this will imply that the relative density of the bottle should be y minus x divided by z minus x. So the answer should be y minus x divided by z minus x. Y minus x divided by z minus x. What is z? If the outer volume of the bottle is z ml, I see no choices as y minus x divided by z minus x. In the choices, it is divided by only z. There is no z minus x. Let me see if I have done any kind of mistake or not. What will be the volume of the solid part of the bottle? It is given that if the outer volume of the bottle is z ml, okay, so if the outer volume is z ml, and we also know that the capacity of the bottle, that is the volume of the empty space, is x ml. So definitely the volume of the solid part of the bottle should be z minus x. It should be z minus x centimeter. Yeah, I think I have incorrectly given the choices. So the answer should be y minus x divided by z minus x. Y minus x divided by z minus x. So the actually okay. So the choice in all the choices A, C, and D, I should have written not z but z minus x. Anyway, so the relative density is y minus x and z minus x. Now remember that the relative density is a dimensionless quantity. It has no unit. So obviously, by seeing the choices, you can right away say that choice A and C cannot be correct because they are mentioning some unit. So the relative density of the bottle will be y minus x divided by z minus x. Okay, let's see the next problem. A body weighing p gmf, that is the mass of the body is p gram, has a relative density q. Okay, when it is dropped in a measuring cylinder, the reading changes from x ml to y ml. Okay, so clearly we can say that so the change in volume, the change in reading in the measuring cylinder is y minus x ml, and that should be the volume of the body. We know that when a body is immersed inside a liquid, is immersed in a measuring cylinder. Measuring cylinder is basically used to measure the volume of a irregular shaped body. If you if you immerse any irregular shaped body inside a inside a measuring cylinder containing a liquid, the level of the liquid or the reading of the measuring cylinder increases by an amount which is equal to the volume of the immersed solid. Okay, okay. Now, then which of the following choices is are correct? Some choices are given. We have to select which one, which of the choices are correct. More than one choices can be correct. Okay. Now the a body weighing pgmf. So definitely we can say the mass of the body is p gram. Okay. The relative density is given to be q. So this implies I can say that the density of the body is q gram per centimeter cube. Okay. Also I can say the volume of the body will be equal to the difference in the reading in the measuring cylinder when the body was dropped inside the measuring cylinder. So I can say the volume of the body will be equal to y minus x, this much milliliter, which is equal to y minus x centimeter cube. So I know the volume of the body, I know the mass of the body from here, and I also know the density of the body. So from the formula of density is equal to mass by V. So this implies the density of the body is given to be Q. No, the relative density was given to be Q. So the density of the body is Q gram per centimeter cube. So we have Q is equal to m by V, mass is P, and the volume is y minus x. Okay, so this implies that P is equal to Q multiplied by y minus x. P is equal to Q into y minus x. So definitely the choice C has to be a correct choice. Now let me see if any other choices is correct or not. Choice A says mass of the body is P kilogram. No, the mass of the body is P gram, not kilogram, P gram, because it is given, the weight of the body was given as P GMF. GMF is a gravitational unit for weight or force, which means that P GMF, a body having a weight of P GMF, means the mass of the body is P gram. The small g stands for gram. So this is incorrect. Choice B says density of the body is Q into 10 to the power 3 gram per centimeter cube. No, the density of the body will be Q gram per centimeter cube. So this is incorrect. Let's see choice D. The volume of the body is y minus x multiplied by 10 to the power minus 3 centimeter cube. No, the volume will be y minus x centimeter cube. So this is incorrect. So only choice C is correct. Okay, let's see the next problem. The density of a liquid measured in SI is found to be P kilogram per meter cube, and the relative density is capital M. The density of the liquid measured in CGS is found to be Q gram per centimeter cube, and the relative density is capital N. Okay. Then which of the following choices are incorrect? We have to now select the incorrect choices. Now what is given? It is given that for a liquid, its density in SI is, let's say, so basically the density of the liquid and its relative density are measured in the two system of unit, that is SI and CGS, and their values are given. So for the SI it is given that the density is P kilogram per meter cube, and the relative density is given to be capital M. For the same liquid, the same measurement in the CGS is given to be the density. Let's say for the CGS system, I'm considering the measured density. I'm denoting the measured density to be rho dash, and the measured relative density to be RD dash. So in the CGS system, the density of the liquid is given to be Q gram per centimeter cube, and the relative density measured in the CGS system is given to be capital N. Now the concept is that the relative density of a substance never depends on what system of unit you are using. If you consider, if you find the relative density of a substance by using its density in the SI, whatever value you will get the same value if you use CGS system for its density. So always remember that the relative density of a substance never depend on what system of unit you have used, whether you have calculated the relative density by using the value of density in SI or CGS. It does not matter. It will be same, constant, same. So RD should be equal to RD dash. This implies M should be equal to N. M should be equal to N. Okay. This is the first thing we know. Now, also, definitely, the value of density will be different if you consider SI system and CGS system. So, in the SI system, the density is given to be P kilogram per meter cube. Now, if I convert this value of density in the SI to CGS system, CGS unit, P kilogram per meter cube will be equal to P multiplied by 10 to the power minus 3, this much gram per centimeter cube. Also in the problem it is given that the density in the CGS system was found to be Q gram per centimeter cube. So we must have P multiplied by 10 to the power 3 minus 3 gram per centimeter cube should be equal to Q gram per centimeter cube. So this implies that P multiplied by 10 to the power minus 3 should be equal to Q. This implies that P by 1000 should be equal to Q. This implies P should be equal to 1000 times Q. So these two information we are having from the given problem. That is, M is equal to N and P is equal to 1000 Q. Now we have to choose which choices are incorrect. Which choices are incorrect? Definitely choice A, it is given P is equal to Q. No, P is not equal to Q. Even though M is equal to N, P is not equal to Q. So we have to select this one. This is an incorrect statement. The problem has asked to find which choices are incorrect. So this is an incorrect statement. And now by marking it with the right sign, I do not mean that this statement is correct. I mean that this choice need to be selected as an answer. Okay. What else? P equals to Q, which is definitely incorrect. And M greater than N. So this will also be selected. Choice A and choice B are incorrect. Choice C says 1000 P is equal to Q and M is equal to N. 1000 P, no, we got P is equal to 1000 Q. P is equal to 1000 Q. I will quickly check whether I have, so P kilogram the density in the SI was given to be P kilogram per meter cube. So P kilogram per meter cube, if I convert this to CGS, it will be P multiplied by 10 to the power minus 3 gram per centimeter cube. Okay. So we will get P multiplied by 10 to the power minus 3 should be equal to Q, since it is also given that the density of the liquid in the CGS system is Q gram per centimeter cube. So P into 10 to the power minus 3 is equal to Q, which means P is equal to 1000 Q. So definitely choice C is also incorrect statement. So this need to be selected. And choice D is P equals to 1000 Q and M less than N. So this is also incorrect. M is not less than N. M is equal to N. So all the choices need to be selected. All the choices are incorrect. Okay. So this brings to an end in solving another set of 8 multiple choice questions on the relative density of a substance. So if you have missed the part 4 video where I have discussed about the key concepts and formula on the relative density of a substance, then I strongly suggest that you should also watch that video, that is part 4 video. Once again, if this video was useful, then please like it, share it with your friends, and support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next video, that is part 6 video, not part 6 but part 7 video, I will start discussing about how to measure the density and relative density of irregular solids and liquids using certain standard devices like measuring cylinder, density bottle, then the big Eureka can, all these concepts related to problem solving. So please stay tuned for the next video. That is all for this video. Thanks for watching, and until the next video, take care and bye.